turn the water on. Okay, so here's the water. Again, you don't want to turn it up high. That's a nice moderate rate of flow. The water is coming from this tap in through these coils. And those coils basically do the same thing that the condenser does. This is really a condenser, right? So whatever vapors, because we're going to heat this water up here, whatever vapors of the solvent makes its way up in here, these are hot vapors meeting a cold surface. They are going to condense and drip down in here. Okay? So there's really not much difference between the condenser and this part of the rotovap. The difference is the vacuum. And so once you have the water flowing, this is clean. I'll put this here like this for now. This is the vacuum that's connected to here. So it's in this direction now, 90 degrees, like so. Okay. And this valve, we turn horizontal. Okay. And then we test. It's sucking my finger in. That tells me it has a good vacuum. And so does this. I always love doing that. Sorry, Megan. Okay? You always test it. Once you have this vacuum on, you could put on your flask without even worrying that it's going to fall into here. Okay? But if you don't have the vacuum on, it will fall in there. Okay? So having the vacuum on is really important. You turn the vacuum on here. You make sure that this is horizontal. And before you do anything, test it. Okay? So we put that on. And this probably could do with some more water. Let me turn this up. And you could bring this up here. It doesn't matter if it's wet. Yep. So I'm just adding more water. And for those of you back there, we do have controls on here where you could turn on the power to start heating this. And you could change the dial so that it gives different temperatures. And let's turn this back down.
Let's not electrocute ourselves.
Yeah, isn't that bad? It's like that.
Okay, so we've turned on the heat here to heat the water up. And you don't have to wait until this water is heated before you begin. Just get it going, and as it heats, this process goes along. So now, in this particular case, this one is controlled in terms of putting it into the water this way. Again, for those of you who are in the back and not seeing, there's this knob that you can twist. So we twist it this way, and then we slowly, this one needs some grease or something. Like that. You don't put it all in, to cover a hole there. Just immerse the flask. Okay? So it's called a rotovap. So what does that mean?
Rotovap.
Needs to rotate. So we turn on, again, there's another dial knob here that we turn on. Oh, it's already, and this could control it. I think this one isn't working too well. It automatically comes on. All right, so when do you stop? How much volume, how much ethyl acetate did we use in the extraction? Do you guys remember?
25.
25?
Or was it 35?
Around 35 the first time.
The 45. Yeah, the last one was 40.
So we used maybe close to 80, 70, 80.
Yeah.
So when you come to ask me, well, when do I stop? Well, the ethyl acetate is not your product. You're trying to get rid of the ethyl acetate. So at least 70 to 80 mils, which is like most of this, needs to be evaporated away. So we're going to assume here pretty soon that it's evaporated away. But before we do that, one of the things that you should not be fearful of is allowing this volume to go all the way down. In some cases, you might get a solid forming or something syrupy. Your product is not going to be evaporated away. Okay? So you don't have to worry about that. Just let it go until nothing more, until it's constant. There's a constant volume. So I'm going to assume two things. One is that we are finished, or two, remember we have this to add, that we need to take this off and add more or take it off because it's completed. How do we go about taking this off? Stop the rotation. Okay, we stop the rotation. What do you think we should do next?
Turn off the vacuum.
Very, very good. You will not win with the vacuum on. The vacuum always wins. Turn the vacuum off. You hold this, because now you're turning the vacuum off. What next should I do?
Turn the thing.
Break the vacuum, right? And listen very carefully. You'll hear a sound. It's gone. And at that point, you hold on to both of these and just twist. Do not pull. Just twist. Okay? That's it. Who wants to do it? Go ahead. Put it back on.
Okay. So turn this way.
Yeah, the vacuum on. I would always have a routine. So my routine would be turn the vacuum on first.
First, okay.
And then turn that knob horizontal. So you have a habit, you know?
Okay.
And then you always test.
Okay.
There you go.
It's working.
All right, and then you can just pull it down. So you have to this, and then put pressure. Yeah.
Okay. Now we gotta turn, make it
Just-
The power. Yep. And I think it's going to turn. This is kind of messed up.
Alright.
Okay. So who wants to come take it off?
I volunteer.
Let's go with Isabel.
Isabel, you volunteer.
I see you, Wilson. You're not lost.
Let's see, so you turn it
Turn
off,
off. Yep. Yep.
then you turn the vacuum off.
But hold.
Hold this. You need to put this up. First.
First, you need to pull it
Yeah,
up.
you can- yeah.
This way.
Yep. And then bring up. Yep. Very good.
You hold this.
Hold the flask.
Turn this off.
Turn that off.
This down.
Uh-huh.
Still wet.
Okay. Yeah, leave it there, leave it there, leave it there. Now you could hold both.
You hold this, and then you
And
don't
then
pull
twist.
it.
You twist.
Very good. One last person to put it back on.
Smells like nail polish.
Okay. It's just water. All right, so one last person and then we move on to something else. The vacuum is on. That's there. Very good.
Nope.
Okay. Uh-huh. We need to like put some oil in that thing.
You're good.
Very good. So give a round of applause to Megan, Isabel. So there's going to be a lot of you doing extraction, then drying, right, with the anhydrous salt with the drying agent, filtering into a round bottom flask, and then rotovapping. When all of the solvent is gone, essentially what remains is your product. Now, if you have a solid, we'll show you the process for getting a solid out from your reaction mixture. And we make up something here. So, let's say ammonium chloride, some ice, because that's what you will do at the end. So just imagine that at the end you have your flask, your round bottom flask, and it has that mixture, and the mixture looks like a solid. And just to kind of make it look like that, I'm going to pour some of this in here. So this came, imagine that this came out of your flask, right? You put it into ammonium chloride, sodium chloride, hydrochloric acid, whatever. And now you want, this is your product, that's your solid product. Now you want to get that, then you have to set up vacuum filtration.
Yes.
So, let's get that going over here.
Are you just gonna let that
There's
go?
the vacuum, so I might need some
Okay.
space. So, to do vacuum filtration, we use this. Again, we have different sizes of the vacuum filtration. What makes these different is that they have this side arm. You guys notice that? If you compare this to, this is a straight Illinois flask. This one is an Illinois flask with a side arm used for vacuum filtrations. And so this is what you need to use. What you never, ever, ever want to do, well, there are two things you never, ever want to do, is use this for the vacuum. Why not?
Because the hose will collapse.
It will collapse.
Can we see a test version?
He did.
Here's the test.
Looks like a needle.
Compared to this, which will not collapse. So you never want to use this for doing a vacuum. You also never want to do this. Let me see if illustrate might be better. Yeah. Yeah. Right. Oh, wow. Oh. You don't want to do that. Okay? I did a little dramatic stuff there, but yeah, whatever.
Such a good role model.
Such a good actor.
What you what you want to do is secure the flask first, always. Secure the flask. Yeah, it wasn't tipping over here, but I would still secure the flask. That should be like number one. And this is secured here. And now you could put the hose on. And to do this, we need to make sure that we are pulling a very good vacuum. We will not do, so we could use these are called butyl funnels. We have some that are like plastic. It doesn't matter if it's plastic or porcelain.
Use the plastic.
And if I were to do it like this, you can hear the air, and part of it is because there is not a really good vacuum there. So you have to use these here.
Not the red. Not the red.
And that helps the vacuum. Okay. So you have that. You're a mess. You take your filter paper, and if you get closer, the part of the reason for putting this filter paper in there, of course, is to make sure. Let's turn this off.
We don't have to hold it or anything.
So these has holes in it, right?
Yeah.
And if you're trying to collect the solid could get in these and go all the way through. So you do have to put the filter paper to collect the solid on top of there, right? So we do that. But in addition to that, what we normally do
Wet it
is
with water.
before you pour your liquid, your mixture in here, which is over here, before you pour that in, is to wet this. Because that keeps the paper right smack onto the funnel. This is called a Buchner funnel. Buchner funnel. So nice and wet, and then you pour your liquid, your mixture with your product. And if this could happen to you, what you could do with product stuck on the side is just rinse it out right directly into the flask. Yep, I think we got most of it. So that's what you do when you have a solid product, when we expect a solid product, when you see a solid product. It doesn't mean that sometimes we may actually, to help purification, we may actually take this solid and do extraction as well. We'll cross that bridge when we get to it, But that's what we do for solid products, is do this vacuum filtration, and for liquid products, we do the extraction. Okay? Any questions so far? So we've shown you how to do room temperature reactions, ice bath reactions, using the drying tube. We showed you reflux, how to treat the products, liquid and solid. See what else.
I mean, time to go.
I think we showed you guys this in grade 10 maybe? I don't know. But if you have to, at any point, use a pH paper to test the acidity or whatever of a solution, here's some acid. Let's say we have to test it. What you don't do is just use the entire paper. This is kind of tight. Is don't just dip the whole entire paper. Is take a glass rod, for example, and put it into the solution or whatever, and then just spot it. So you could use